Hello friends, welcome back. We will continue with the pixel art activity. In fact, now we are at a very interesting point where we have learned previously how to create a two-dimensional grid of squares. Now we'll see how we can again use the if, elif, else condition to create a huge number of patterns on this grid. But for that to happen, we'll have to understand these dynamics a little bit better. And that's what we are going to do in this video. And I'm going to give you many examples so that you can try yourself and get more familiar with this. Now, remember the way we created this two-dimensional grid was using a for loop inside another for loop. What that also means is that I have got with me two variables, in this case jj and kk, to tell me where I am on this grid. So for example, kk is a row index, which means kk is 0 in this row, kk is 1 in this row, kk is 2 in this row, all the way until kk 19. And jj, like previously, is the column index, which means 0, 1, 2, and all the way until say 19, right? So notice this is 0, 0, this is 19, 19. In effect, what we have created here is a grid for which each square has an address, and the address is given by kk and jj. And now we can do a lot of things. For example, let's say we wanted to make every rectangle, let's say on the lower half of this as red, right? So how do I do that? Remember, I've got I've got basically kk as row index, jj as the column index. So before when I come to the second loop, I can put a condition. For instance, I can say if say kk is less than 10, then okay, again I have to be careful here, and I must indent this, right? So if I do this, if kk is less than 10, draw a rectangle of say green color, else say draw a rectangle. So again, I can just copy this line, draw a rectangle of say red color, right? Now what's going to happen here is that for the top 10 rows, because remember kk will start at 0, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For the top 10 rows, the condition if is true, which means it's draw a green rectangle. For the remaining rows, the else condition is true, hence it will draw a red rectangle. And in fact, there's nothing else that I have to change in this code. If I run this, I expect to see half red and half black. So when I run this, that's exactly what I see, that the first half is all green, the next half is red. Now you can do it obviously by using if, elif, else. You can make it, let's say, three colors, first five rows in some color, next five rows in some other color, and remaining five rows in some other color, right? So here it will become if, elif, else. Now let's do it a little bit differently. Let's say I want the second half of the columns to become red. Again, it's very simple. Instead of kk, if I did, let's say, jj is less than 10. So what's going to happen here is that, remember, for every row, I'm going to go to the column, and in every column, if jj is less than 10, which means the first half, I'm going to draw a green color, else I'm going to draw a red color. So if I just run this very quickly, I'm going to get a situation where the left half is green and the the right half is uh, red, right? Now again, you can draw this differently by using if, elif, else. You can have multiple conditions getting created, and hence more things can be drawn. Now let's look at something a little bit different, right? Let's say I wanted all the elements, all the squares which are on the main diagonals, and the diagonals, remember, are the ones that cut across. Notice here I have got, for this square I've got jj equals to 0, kk equals to 0. For this square is first row first column, 0th row 0th column, first row first column, second row second column, third row third column, fourth row fourth column, and so on and so forth. Which means that if I, let's say, wanted all these squares to become say a certain color, say red color, all I really have to do is to change my if condition here, and I can say if jj is equal to kk. Now remember, whenever I have to check for equality, I have to use double arrows. Uh, so what's going to happen? Actually, we should I'll use reverse condition here. Jj is not equal to kk. Uh, then it will draw green color, else it will draw a red color, which means that everywhere I'll get a green color except this diagonal where I expect to see a red color. If I do this, let's see what happens. Uh, so I click run, and indeed that's what I see. Notice on the primary diagonal I got red color. That's because on these lines, this condition is actually JJ is actually equal to KK, so it goes into else. Otherwise, it draws here, right? Now, let's say I just reverse these conditions, right? Like I was doing previously. Um, if I did this, then I expect to see an exactly inverted picture from what we just saw, right? So I notice everywhere red, but I've got that main diagonal is green. Let's look at something a little bit different, right? Let's say I want everything to be red, but say I want this diagonal, which is the that the let's say the other diagonal of this to be becoming green. Now, how do I do that? You have to think a little bit carefully. Notice what's happening here. In this particular point, my KK, which is the row index, is 0, but my JJ is equal to 19. Remember, both of these go from 0 to 19. KK is 0, JJ is 19. Over here, I've got KK is equal to 1 because, second row, but my JJ is equal to 18, right? Because, I'm talking 0 to 19, right? In fact, if you think about it, if I make my condition, let's say if JJ plus KK is equal to, say, 19, then I want to see a green line. Otherwise, it's red because along this next diagonal, the JJ and KK are such that their values will be, remember, this is KK0, JJ19, and this is KK19, JJ0, right? Which means that along this diagonal, you can convince yourself that the sum of these two will be equal to 19. And if I did this, notice what I get is exactly what I thought, right? I got everything red, but this diagonal is colored differently, right? In fact, you can, really explore this thing quite, let's say, intensively, I would say. However, this requires a little bit of mathematical thinking, little bit of geometrical feel for what's going on. Let's take a few more examples, right? Let's say I want to make every element on this portion, which is the top half, to become, let's say, green, and the remaining part remains, uh, remains red, right? So what can I do here? Notice that if I look at, let's say, this pixel over here, so what have I got here, right? We have got JJ is 19 and KK is equal to 1, right? Which means that for these pixels over here, I have got a situation where JJ plus KK is actually more than 19, and you can convince yourself. Take any pixel, right? Let's say we take this pixel in between, right? So here we have got, say, row number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, let's say. So which means KK is 11, and then I take, so 11, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So let's say we took at this pixel. So my KK is 11, JJ is 9, which means KK plus JJ is again more than 19, right? So if I just change this, for example, to say greater than 19, then make it red, I expect everything here to become green and everything on top to become red. And that's exactly what I expect. And in fact, that's exactly what I see. Now, why did the main row become, become red as well? I mean, notice that it's the top, this diagonal has also become red because I've strictly put greater than. Remember, this line, this diagonal we just saw was a situation where JJ plus KK was equal to 19, right? Now, on the other hand, let's say I just make it greater than equal to, which means it could be greater than or it could be equal to. In that case, I'll get a situation where I will have, this row becoming green, right? So, you can really, really, really experiment with this, get like hundreds of patterns. It's a great practice for mathematics, right? It's a little bit like how we created these patterns in our sprites that we were doing earlier, right? So you can really create lots and lots of patterns. I leave that as an exercise for you, and I'll just leave it here. I just maybe give you one more example. Let's say using if else else. So what I could do, for example, is that let's say I want a three color pattern. So what I could do, for example, along similar lines, right? So I say if JJ plus KK is, say, less than 10, right? Less than 10, maybe then I'll, let's say I draw a green rectangle. Here I put, say, LF, and my condition is KK plus JJ. JJ is, say, greater than 9. Notice this is actually very similar to what we had done in the one row case, right? Just that it's a little bit more involved here because of two dimensions, but it's also more interesting for the same reason, right? So here, for example, let's say I make it, let it be red, and then finally I'll put an else condition, right? So I put an else condition over here, and I just put this statement, same statement, control C, and then I say control V. I have to be careful about the indentation. All of this if else has to be inside the second, which is the inner for loop, right? Now here I can possibly put, say, blue color. Say let's put blue color here. And what I now expect to see is three regions, three diagonal regions. Sort of notice the top half is green, in between I've got red, and then later on I've got this blue. Now let's just briefly understand what we are saying is JJ plus KK less than 10. Remember, this side is always 0, 0. This is, so let's look at, so this is KK equals 0, JJ 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Which is, so JJ plus KK is less than 10, hence until 9 all these squares become green, and you can convince yourself in the same logic that this all will become blue and this will become red, right? Now this is something you'll keep getting better and better as you practice more, but and that's the best way to really master this thing. But really the possibilities, as you can imagine, are really really infinite. You can do lots and lots of things by just using this if elif else statement, and of course a little bit of mathematics, keeping always in mind that each of these squares essentially has an address given by JJ, KK. KK is the index of the row, JJ is the index of the column. So now I can run, like, all kinds of rules to color them the way I want to. I hope you found this interesting. Take care. Thank you so much. Bye bye.